Today we're gonna solve this problem, find ABC. Chef has three hidden numbers ABC such that ABC are lying between 0 and n inclusive. Let f be a function such that fi equal to a XOR I plus b XOR I plus c XOR I. So you are given all the values from f0 till fn and you have to determine value of ABC. If there are multiple possible values of ABC, you can print any of them. So let us look at the test cases more. So like here we are given the n plus 1 values, so 2, so there are 3 values f0, f1 and fn, 0, 3 and 6. So one ABC value satisfying would be 0, 0, 0, and for this it would be 2, 0, 2. So for let's say for test case 1, f0 will be 0, ABC 0 will satisfy. So f0 is 0 or 0, 0 or 0, 0 or 0, that is 0. f1 will be 0 or 1, 1, 1, 1 will be 3. So you can see all f0 till fn are satisfying these value for ABC. So you need to find any tuple that satisfies this condition. Okay, so for second test case, A2, B0 and C2 will satisfy it. You can put all the values and check that all fn values are coming out to be correct that are given in the problem. So let us take the first test case and let's see how we can solve this problem. So 0, 3 and 6. So 0, 3 and 6 we need to do. So let's say we have this A and I need to find out this ABC, B and C also, but let us just focus on A for now. So if I somehow have this bits of A 0, 1, 1, 0 anything, and if I know for each bit that it need to be turned on or off for this particular value of A, then I know what my A should be and I can do the similar thing for B and C also. So I will think this question bitwise. So I will think that this bit need to be turned on or off in for satisfying my condition. Okay, this will be my goal. So 0, 3 and 6. So this is for f0 and this is f1, that is 2 to the power 0 I can write, and this is f of 2, that is I can just write 2 to the power 1. Okay, this is 0, 1, 2. Okay, so what is f0? Let us take a look. So f0 will nothing but A XOR, I can write it like this, so XOR 0 plus B XOR 0 plus C XOR 0. This will be my f of 0. Okay, and I know any number XORed with 0 is that number itself. So this will be A plus B plus C equals f0. Okay, so I have one equation in ABC. So this is an arithmetic equation. If I somehow could find two kind of similar equation arithmetic, then I can solve just by doing simple mathematics, because there are three variables and three equations I need to solve. But this is not possible in this case because the equation, the next coming up equation will involve this XOR and they will not be arithmetic and we cannot solve it like this. I am talking about this 3 variable 3 equation kind of solution. So this is not valid. If this was the case, then the question become really simple. So we have to think in somewhat like more complicated fashion. So this we cannot find more equations something like this. But what we can do is focus on the powers of 2. Why I will need to focus on power of 2? Because I said you, for determining A, I will check for each bit. If somehow I could determine that this bit should be on or off, that is my ultimate goal. So each bit is nothing but just the power of 2. So I will be more focusing on the power of 2. Here are all the powers of 2. So we have a simple case. So f of 2, 0. Let us focus on what this gives us. So this gives us f of 0 always gives us the sum of all the three variables. So f of 2, 0, what it gives us is like f of 2, 0. So let's just focus on this first term and rest will follow up. So f of 2, 0 is just A XORed with 2 to the power 0. So if let's say this bit is in the final answer, this bit is on in A, and the second case would be off in A. So if this is on in A, then XORed will come out to be 0, because bitwise I am talking. So let's say the ith bit I am talking here about A. So ith bit of A I am talking about. So in the ith bit of A, okay, so let me just rub and so ith bit of A I am talking about, and I am talking about f of 2 0. So what it give me, just I am focusing on A all for now. So 2 to the power 0 plus B and plus C also will be here. So let's just focus on this, and for ith bit let us check this. So ith bit here would be I equal to 0, because this is my I. Okay, so now if this there are two cases, this bit is eventually off in my final answer and this bit is eventually off in my final answer, two cases. So if this is on, then this is also on. So on 1 1 1 XORed 1 will be 0, so this will come out to be 0. If this is off, then this is on, this bit is on, this is off, so it will come out to be 1. Okay, so there are two possible scenarios. So I need to somehow make use of this and get a final conclusion whether this bit should be on or off. This I can do if I just write one thing like f of 2 to the power 0, I subtract it with f of 0. Okay, and what this gives me is actually interesting, and I should also divide it by 2 to the power 0 also here. So this is somewhat like not intuitive, I would say, but like you will get why we are doing this, because this is actually the result will come out to be really simple. So f of 2 to 0 is, we have seen, can be 1 or 0. So let's say if this the ith bit in A is on, so this f of 2 to the 0, if the in A this ith bit is on, so 1, and we XORed with 1, this is what my f of 2 to 0 was representing, so it will come out to be 0. Okay, so this expression comes out to be 0 minus f of 0. So this bit was ultimately on in my A, so this f of 0 will give me 1. Okay, and I divided by 2 to the power 0, here it is 1, so nothing changes, and it will give it to be minus 1. So what this minus 1 represented, the bit need to be turned on, Okay, this is my very crucial observation and result. If this expression comes out to be minus 1, that means this bit need to be turned on. And the second case, what it can be is like f of 2 to the power 0 minus f of 0 upon 2 to 0. Let's say I took the case where the bit was eventually on in my answer. It might be that it was off in my answer, and what my 2 to the power 0 represent is XORed with 1. So 0 XORed 1 will give me 1. So this will give me 1, and this will, what it will give me, f of 0, so it was eventually turned off, so it will give me 0. Okay, f of 0, and 2 to the power 0 is nothing but just 1, so it will give me 1. So previously I was getting minus 1, which means that bit needed to be turned on, this bit, and 1 means you don't need to anything, don't do anything. Why? Because 1 means if this bit was eventually turned off, it is already turned off, and if this bit was turned on, it is already on. So essentially what this 1 means, you don't have to do anything. So similarly the case for B and C also will be done here, and what will I will getting is okay, so this expression f of 2 to the power, let's say I, minus, in general, and now I am writing f of 0 upon 2 to the power I. So this expression, what this value can give me. So for A, B, C, for all these three variables, it will give me something. So for 1, it can give me plus and minus 1. B and C also, it can give me plus and minus 1. So plus minus 1, it can also give me C. So if you do simple maths, like if this these are 2 are plus 2 and this is a minus 1, you will see that you can only get only 4 possible value, that is minus 3, minus 1, plus 1 and plus 3. You can see like minus 3 I can get when all these 3 are minus 1, and plus 3 I can get when all these are plus 1, and plus 2 are plus 1, then it is 2, and minus 1 will be giving me minus 1, something like that. So you can check all these are only the 4 possible value you can get out of this scenario. So this is the main observation expression, I would say, in this problem. So this will decide, and these all value what it means, I will just explain it now. So what this minus 3 means? So minus 3 minus 1 meant that you need to turn this bit on. So minus 3 means in A, B, C, all these are minus 1, then only this minus 3 came out to be. Okay, so this means that you need to turn this bit on in A, B, C, all of the 3, you need to turn on this bit. So we will do that. So what this next value would be minus 1. How minus 1 can came? Minus 1 can only came like minus 1, and other would be plus 1 and minus 1. Okay, so minus 1 can only become when 2 of them are minus 1. So plus 1 you don't have to do anything. So minus 1 means in 2 of them, in 2 of the 3 you need to turn on this bit, but I don't know which 2. So A and B, B or C, A or C, which 2 I need to turn this bit on. So that we will discuss later, but for now we will just do it in A and B. Okay, and why this is not completely correct, and we will have to eventually make this correction later on. So we will handle it later. For now we will just choose 2 A and B, and we will increment that bit in that. So plus 1. Okay, so these are all the cases we need to handle. So plus 1, what plus 1 means, how plus 1 can came? So plus 1 and minus 1, this how it can came. So pick out of 3 you have to pick any one, A, B, C, and you have to turn that bit on. So I will choose by default A. By I am choosing, again I have to handle it later, because in the problem it is asked that you need to find any tuple. I can somehow form the tuple and give my answer if there are multiple satisfying. So I am just incrementing my A. Okay, so that is it. And what eventually can be done. Okay, so let me just explain the code till now, and we will now then move on later. So I input it, and I input n plus 1 values in this vector, and what I do is A, B, C are 0, and till 20 I move on. Why 20? You can also use 32, it will not affect the answer. So if the current power of 2 is greater than n, that means I have to stop, and this bit is not relevant. So this is, I am moving in the power of 2. This is that same delta I was calculating, f of 2 to the power I minus f0 divided by 2 to the power I. So if this delta is minus 1, this bit is needed to be turned on in all of the 3. You can use also or plus, doesn't matter. You need to turn on, this bit is on all the 3. If delta is minus 1, then you need to turn off in any of the 2. By default I am doing it in the A and B. We will handle it later, I said. So delta 1 means you have to, this can come out only if like only one is minus 1, other is plus 1 and minus 1. So delta is 1 means you have to turn this bit on in any one of them. So I will even by default turn this on bit A. So here it is 3, you can just avoid this else. I have just written that you should know that delta may be 3. That means that all of the bit is turned already on. So ABC or whatever it is turned off, so you don't have to do anything here. So here I got my ABC, and it will actually you will see that it will satisfy all of these equations. So why I can't just print ABC here? I can just print ABC and it will satisfy. But one condition they will not satisfy is this. So all the ABC should have lie in the range n. Is like I should have incremented A too many times so that it exceeds the value n. So these value might not be in the range ABC. but I can adjust this. So I can adjust this bit. How I can do that? So like, what I can do, so let's say these are like numbers 1 2. Okay, something like this. So let's say this is my n, this is 6, this is my n. So what I can do is like I'm taking the worst case for like n. So this is like 2 to the power 0, 2 to the power 1. Okay, so power of 2 I'm only concerned with. So let's just say that I'm taking worst case of for a, and I somehow incremented all the 2 to the power in a. So a equal to 2 to the power 0 plus 2 to the power 1 plus this. So it might end up here, somewhere here. So this value is 4, 5 and 6. So it is actually under the constraints, but I'm taking an I would say like I'm explaining a point here. So this is actually 6 and under my constraint, so this is not a problem here. But what could have been is like this value might be overflown on this side of n. Somewhere here it should have gone, not exactly which value, but you get the point. So what I need to do is just take this bit. But what this value is like in general, the sum of the power of 2 is just the next power of 2. So this is power of 2, so the next power of 2 minus 1. This is the sum of geometric progression, a simple formula you could learn. So 2 to the power 3 minus 1, that is here it is come out to be 7. Okay, 4, 5, 6, 7. So this is this side 7. Okay, so this is a problem here. So I somehow need to do. So the best way to do is just pick the highest bit and erase it from it. I am very sure that this will always make this value of a inside this range. Why I am too sure of this is the highest priority bit, and taking this will make my sum to be the next largest power of 2 to the power 1, and what I can do is 2 to the power 2, the sum would be like this. Instead of this, now the sum would be this if I just take this off. So 2 to the power 2 minus 1 will surely be under the limit of n. What I am trying to say here is just if the value is greater than n of a or b, then you just take the highest bit and erase it from it. And I have like proven here that it will always work, that taking off the highest bit will make the value smaller than n. So what I did here is, if my a is greater than n, so here you can also use while a is greater than n. While your value of a is greater than n, you keep doing that. But I just proved that only removing the highest bit will do your task. So I just run. I know that this piece of code will run only once. This piece of code essentially. So I don't use while. I just use if. So I do this and I just break. So this part only runs one time. So what I am doing is from highest to lowest I am seeing. So if this bit is already off in a, you don't have to do anything. I am looking for some on bit and I want to transfer it. So if this bit is already off, I just continue. And if this bit is already on in B and C, both of them, then I should also continue, because whom I can transfer. So from A I take this bit and I have to give it to someone, either B or either C. So if this bit is already on in both of them also, I cannot give this bit to any of them. So I can continue. So when I find my right bit, I just decrement this k counter. So I turn this bit off, and C is my smallest value. By default, I am putting my values in such a order. So I increment this bit in C, and I just say that okay, J is this bit, and I just break it. J will be useful in this. So same I do this for B. If the B is also greater than N, I do this, and if C, then I do this. So this is a simple bit transfer which I am doing here. So again, just we can also use while here, but I know that only removing the highest bit will do my job, so I don't use while here. So at the last I can print just ABC. So I could have print ABC, but the limit was like ABC should be under the 0 to n, so I just adjusted the bits somehow that they come under this range. So this come under ABC like this. So go through the solution again if you have any doubts, and still you have any doubts, and you can search the problem here. So like yeah, like this, you can search any problem you want, you have any doubt, and you can click on the problem in the practice session, and you can see click on ask a doubt. So clicking on ask a doubt, and you will start a chat, and you can interact live with a problem solver that will help you with your doubt. So what are the common mistake that could have encountered? That you are not taking this n+1 values, you are just taking n. So this is a common mistake. And another common mistake would be you are not just considering this power of 2. Another mistake could be like you are just printing ABC here and you are not taking care of the ranges. So ABC is like in the range, so you should also make sure that ABC are in the given possible range. You can just output them. Yeah, that's pretty much it. Thank you for watching. See you in the next video.